I welcome you all to the Spark Research YouTube channel. This is Dr. Veer Chandra, Assistant Professor in the Department of ECE. This is the another session of this series, Gate 2025, and this is the third part of this particular analog and digital communication. So, we have already discussed some questions related to this particular course, analog and digital communication. So you can find the link in the description and you can visit that both the parts of this particular course. Okay, so here is your overview. This is much more important because already we have discussed the 5 questions related to this particular subject. So you may score the marks in the range of the 10 to 15, right. So that is why this is a good courses that you should cover. What are the major topics that included in this particular course? So maybe the random process, then your analog communication, digital communication, and the information theory, right? So these are the major topics. Okay, let's go to the question. So question number 42, you can check it. So question is, consider a real value random variable. So where ft is given is equal to summation of n is equal to 1 to n a n p of t minus nt. So where t is greater than 0 and n is a positive integer. Here pt is given equal to 1, right, and 0 otherwise. So till here what is given? So it is given that pt is a 1. What is this pt? Pt is a function like p of t minus nt. So pt is equal to 1, where if t is in between the 0 to 0.5 t, right? So that is equal, that is your pt, and 0 otherwise. So this will have the value, that is pt will have the value only in this particular region. 0 to 0.5 is equal to how much? 1, right? So and that is equal to pt. The coefficient a and are pairwise independent, and now we are talking about the an. So that's all about the pt in given in the question. An, what is that? An is the coefficient that is pairwise independent, and 0 mean unit variance random variable, right? So an have the 0 mean unit variance random variable. So 0 mean it is already given, right? Now, what are the questions? So read the following statement about the random process and choose the correct option. So here it is given that the mean of the process f is independent of time. So anyway, mean we have to find of this f of t, and then autocorrelation function of expectation of f of t plus t independent of this, right? So, like if you will look into this question, then it appears that the question may be the difficult, right? But this is very easy question, right? How? So, in this question, what are the things are given? It is given that, like it has been given, this is your f of t, which will depends on the p of t, and p of t is nothing, is equal to 1 only. So you can replace p of t minus nt is equal to 1 only. Condition is that the 1 will be only during this time 0 to 0.5, otherwise it will be 0. So otherwise means p of t, this will be equal to either 1 or either 0. So this is the given. And what about an? An have the 0 mean unit variance, already it is given, right? So what are the quantities we have to find? We have to find the mean of this f of t and autocorrelation of this f of t. That's all, right? So let's see how to find out the solution. As per answer key provided by the IT root key, your answer is option is A, means first is true and second one is false. First is true means the mean of your process FT is independent of time, and second, that is autocorrelation is not independent of time. So these are your answers. So let's see how to solve the particular question. So this is your P of t, right? So if you'll remember the question, in the question itself, it is given that P of t have the value 1 in between 0 to 0.5 t. Remaining, it will have the 0 only, right? So now how will you find the mean? So this is very simple. Like if you wanted to find out the mean, then your theoretically you can find out using the mean will be equal to n0, your n is equal to 1 to n and a of n. So here your expectation of A of n and into the P of t minus n of t, right? So that will be the mean. So like now how will exactly find? So mean, this is expectation of E of t. So this is the mean. Exactly how can you find out? So here you can just take it out, the E of A of n, and so expectation of A of n, and then it will be multiply P of t minus n of t. So this is your function P of t, right? So P of t is your equal to 1, right? So now it is already given the expectation of A of n, right? So this is already given that it will be equal to 0. So here if you replace the value of A of n is equal to 0, the 0 into P of t minus n of t. So this will is equal to 1 or 0, right? So it depends on the value of t. So again, since already E of n is given it is 0, so now 0 into the 1 or even 0 into 0, it will be equal to the 0 only, right? So if it is 0 means is this value depends on the t? Of course not. So this is not equal to it is equal to 0. So that is why this is not dependent. So first statement is correct. So independent from the t, right? Now let's find out the autocorrelation. So first of all, what do you mean by this term autocorrelation? So autocorrelation you can find for any function, your RT is equal to your for f of t, like f of t into f of t plus tau, right? So this is the integration of f of t plus tau. Like what is the tau? Just shift your function by some time and then integrate. If you will integrate, whatever the area will be common if you are integrating, moving, like suppose you can just shift your rectangle by t minus tau and move from minus infinity to infinity, and the area, whatever area will be, that will be the autocorrelation. So this is the area. So here you can see, is this independent of time? Of course not. The values are depending on the time, right? So here if it is 0, then it is maximum, value is maximum. So this is depending on the time. So of course a statement is not correct. So this is independent. How will you find out? So here autocorrelation function you can find out p minus t of n minus t. So you can suppose p of t n minus minus n of t is equal to g of f, g of t. So autocorrelation will be g of t into g of t minus t plus tau. So this is your autocorrelation of g of t into g of t minus tau, right? So this is this value, like here if you will find out, if you will replace the value t minus tau, so it will not be 0 and it will have the certain value. So that is why this is not independent from the t. So since the value autocorrelation depends on t false relative to the pulse interval, it will not independent of time. So conclusion is your statement second is incorrect, right? So here overall your mean will be almost 0, means yeah, since E of t is equal to 0, so that is why this is independent of time, and autocorrelation is like this is type of the triangular function, it will be type of this. So it is depending on the time, so it will depends on time. So answer A is correct, where your mean is independent of time and autocorrelation is independent of time. Okay. So that's all in this session. Actually, I thought to discuss only one question so that you may feel that some sessions are going longer. Okay. So thank you to join the session. If you have any, the question, or if you have any problems, you may drop the comments. And also, I'm looking for the comments if you are looking for some different subjects question, right? So we'll come with some different subjects. Thank you to join the session.